Today we're going to talk about learning target 3, which says I can determine whether or not a set of input and output values, which is really just a relationship between two sets of data or two things, that represents a function in various forms. Because some relationships are functions and some relationships are not functions. And depending on if they are or are not, we can do different things with them. In order for a set of input and output values to be a function, each input cannot have more than one output. So what does this look like? In a table, this x stands for the input and the y stands for the output. Think of it like in an equation. X is all the things that you're putting in, and then you multiply it by this and add this, and then you get an output out. X is always the input, Y is always the output. Okay? So now that we have X is the input and Y is the output, we need to think about what it means so that each input cannot have more than one output. So if it is a function, that means if I have all of these values here, let's say, and let's say that 1 is going to be repeated. All of these different inputs, let's say 0 leads to 4. So if I put 0 into my function, my imaginary function, 4 would be what would come out. If I put 1 in, then it's 5. If I put 2 in, then let's say it's, 6. If I put 3 in, then 7 comes out as the output. And if I put 1 in, then 5 is what comes out again. So because each input leads to just one output, this input of 1, it leaves the same number both times. So that's okay. What would not be okay is if you had that input of 1 leading to 5 here, and we'll say leading to a different number down there. This makes it not a function because you have one input that's leading to two different outputs. And in order for it to be a function, each input cannot have more than one output. Here it has 2. This input of 1 has an output of 5 and it has an output of 12, so it's not a function. So why is this second table not a function? You can say because the input 1 leads to 2 different outputs, 5 and 12. Okay? Now let's look at graphs. Just like the x represents the inputs and the y represents the outputs, all these x lines, those all represent different inputs. And all of these y values, represent different outputs. So we want to make sure that our graph never has one input that has two outputs associated with it. So as long as your graph never double backs over onto itself, like for example this, is okay. Because any input you choose just has one output value that goes with it. This input has this one. This one has this one. This one has this one. There's never a situation where one input has two outputs, maybe here and down here or something. What that would look like is something like if you have all of these different inputs and all of these different outputs, let's say you had a graph like this. Now you have one input here, let's say, and there is a value here, and there's a value here. You have one input that's leading to two different outputs. This value right here, it looks like -2, is leading to a +2 and a -4. So this value, this relationship right here is not a function. There is an x value, which is really like the input of the function. That has more than one y value associated with it. Because the y value is really just the output. Okay? We call this the vertical line test. If we can draw a vertical line anywhere on the function and it only hits the function one time, that means that every input just has one output. So over here, anywhere you draw a vertical line on this function, each vertical line just crosses through this function one time. This line crosses through it right there, just once. This line crosses through it right there, just once. Over here, we drew a line essentially right here, and it crossed through two times, there and down there. So this is not a function because it did not pass the vertical line test. So we can write that over here too. Does not pass the vertical line test. Okay? Now, let's think of this in situations in our world. So a function is if we list some sort of element and it just in each of those items, those things in that element have only one thing that goes with it, that's a function. So let's think about people and their birthdays. People is the input. Birthdays is the output. This is a function because each person leads to exactly one birthday. Nobody has two birthdays. Even if they were born at exactly midnight, there's only one birthday written on their birth certificate. So every person has one birthday. So that's a function. Now, let's think of something that's not a function. Let's think about, we could even say, just flip that one. Birthdays to people. There are 365 possible birthdays. There's August 12th. There's January 16th. There's February 4th. There's 365 possible birthdays. And each birthday has more than one person in our world that's born on that birthday. My birthday is August 5th, or April 5th, sorry. So if I put April 5th in, lots of different people have that birthday. So one input is leading to lots of outputs. Me and a whole bunch of other people in our world all have this same birthday. So that is not a function because this one input leads to millions of different outputs. So that's what we can write over here. Why is the second situation not a function? Because each input, each date, really, has thousands, probably even millions, of people associated with it. Okay? Another option could be, let's think of another function here, or another not a function. Day of the week. and outfits. Monday, this week, might be associated with jeans and a t-shirt. So jeans and t-shirt. Monday next week might be shorts and a sweatshirt. Because this day of the week is associated with two different outfits that is not a function. So that is a summary of Learning Target 3. Remember, you can take a minute and just pause this video and copy all of this down if you didn't get it, or maybe you paused it throughout the video. And I hope you enjoyed Learning Target 3.